हेलो फ्रेंड्स, वेलकम टू माय लर्निंग चैनल आर्ग लर्निंग। आज हम डिस्कस करेंगे एल्डिहाइड और कीटोन्स के ऊपर। जेईई मेन में 2026 में एक क्वेश्चन आया था 24 जनवरी पे। क्वेश्चन है गिवन बिलो द टू स्टेटमेंट। स्टेटमेंट 1, cross aldol coupling between two different aldehydes will always produce four different products. While semicarbazide reacts with a mixture of benzaldehyde and acetophenone under optimal pH, it forms condensation reactions or with acetophenone only. So फोर स्टेटमेंट दिया गया है, कौन सा ट्रू कौन सा फॉल्स है। सो फर्स्ट स्टेटमेंट क्या है, टू डिफरेंट एल्डिहाइड्स व्हेन इट रिएक्ट will it give four different products? It is partially true because it will not always give the four different products. What is this? This is the aldol condensation. So let me select a simple example for this plus this acetaldehyde and propionaldehyde. When it reacts, yes, it of course give four different products. But if I react with two different aldehydes, say this is one aldehyde which has no alpha hydrogen, plus this is aldehyde which contains at least one alpha hydrogen, it won't give four different products, it will only give two products only. So the first statement is not true, and I would like to mention what is alpha carbon and what is alpha hydrogen. Alpha hydrogen is that hydrogen that attaches to alpha carbon. And what is alpha carbon? Carbon directly linked with फंक्शनल ग्रुप। मैं ये क्यों बोल रहा हूँ, ये पता नहीं है कि अल्फा कार्बन कौन सा होता है, बीटा कार्बन कौन सा है, अल्फा हाइड्रोजन कौन सा होता है, बीटा हाइड्रोजन कौन सा होता है। मैं एक सिंपल एग्जांपल के थ्रू ये डिस्क्राइब करना चाहता हूँ। सो दिस इज द हाइड्रोक्सी ग्रुप और एमीन ग्रुप। ये जो फंक्शनल ग्रुप है हाइड्रोक्सी और एमीन, ये इस कार्बन के साथ अटैच है। दिस इज नंबर 1 कार्बन, सो दिस इज अल्फा कार्बन and this is beta carbon, this is gamma carbon. ये अल्फा कार्बन के साथ जो हाइड्रोजन अटैच्ड है वो हाइड्रोजन है अल्फा हाइड्रोजन एंड ये है बीटा हाइड्रोजन। But if I give another examples, so this is aldehyde, so here is H. Is it alpha hydrogen? No, this is not the alpha hydrogen because this is now the functional group which contain a carbon, so that carbon will not be counted. ये कार्बन काउंट नहीं होंगे। जो ये जो फंक्शनल ग्रुप है इसके साथ जो कार्बन अटैच होंगे यही होगा आपका अल्फा कार्बन, और इसका साथ जो हाइड्रोजन अटैच होंगे यही होगा अल्फा हाइड्रोजन। ये याद रखना, कोई भी हो। दिस इज कीटो, this carbon is carbon from functional group, so it will not be counted. So this is the alpha carbon, this is also alpha carbon, this is beta carbon. If something is there, this is also beta carbon, this is gamma carbon. So like this. Similarly for carboxylic acid, for ester also the same principle will follow. So now we understand what is alpha carbon, beta carbon. I will explain the mechanism of this aldol coupling reaction, why it gives four reactions, but let me solve the second question. So this is semicarbazide, NH2, NH, CO, NH2. This amine is more basic than amide. This is less basic. So when it reacts with any carbonyl group R equal to A or alkyl or allyl, it will react from this nitrogen and gives the following semicarbazide. It is irrespective whether R is aldehyde or keto, aromatic or non-aromatic. It will give the product N, NH, CO, NH2. So this is R, R is H, alkyl, aryl. It means that this statement is also not true because it says that it reacts with acetophenone only. Acetophenone means R equal to phenyl, and this is methyl. So this is not react with acetophenone only, but this is react with benzaldehyde also. So statement 2 is also false. So now which one is the correct statement? Both statement 1 and statement 2 are false. So 2 is the correct statement. This is a simple questions but with logics, because the main logics is lying here. Always gives full product. No, this is not true, this is partially true. If it does not contain any alpha hydrogen, any of the two, then it will give two products. Now, what is the mechanism of aldol condensation? You can skip this if you already understand the mechanism of aldol condensation. So, it contains one alpha hydrogen at least. So, this is alpha hydrogen. Since both contains alpha hydrogen, so if we treat with base, it abstracts either this proton or this proton. It gives mainly this one minus, and also this one will also give minus. So if it is in a mixture, now what happens? So this will undergo self-coupling reaction. So it will react with another aldehyde. So this will attack here. So 1, 2, 3, 4. So 1, 2, 1, 2, 3, 4. So this is aldehyde. 1, 2, 3, 4. Two positions में होंगे hydroxy. So this hydroxy is unstable. So it will undergo dehydration reaction to give this aldehyde. Similarly, AB cell coupling होंगे. It will attack here and it will give 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, and this 3 position hydroxy will be there. Then 5 position will attack. This is 5 carbon, and here is 4. Then aldehyde will be there. So this is unstable and undergo dehydration reaction to give double bond here. 1, 2, 3, 4, 5 aldehyde, and this is 1. So similarly, this will also undergo cross-coupling reaction. So one will attack aldehyde. Similarly, the other will also attack here. So it will give two different products. One very interesting thing is that this is straightforward, but you can see this is a branch. So remember, whenever the two coupling will be there, so branching will always add two positions of the aldehyde. If it is long chain aldehyde, two different aldehyde did coupling reaction or underwent aldol condensation, and it gives 4 different products. One of the 4 different products is something like that aldehyde. Here some branching will be there. So this is not possible. The two aldehyde cannot give this type of product. So this won't be aldehyde. One of this would be ketone. So whenever two aldehyde underwent condensation reactions, always substitution at alpha positions or 2 positions. This is 1, this is 2 position. So you remember this one. This is all. Thank you so much. मिलते हैं next video में. Bye bye.